Hi friends, in the continuation of data science interview question answer series, we are moving to question difference between dropout and early stopping method category. A regularization technique modifies the network structure during training is called dropout. Early stopping, a model selection technique modify the training run duration mechanism. Dropout randomly set a fraction of neurons to zero at each training steps. Early stopping monitor a metric, example loss or accuracy on the validation set and hard training when improvement plateaus when applied dropout applied during every forward and backward pass of the training process. Early stopping applied at the end of each epoch to check the validation matrix. Primary effect dropout prevent co-adoption of neurons, forcing the network to learn a more robust distributed representation. Early stopping prevents the model from training too long and starting to overfit the training data, capturing noise, variance, bias, impact, dropout, reduce variance, act like an ensemble of a thinner network without significantly increasing bias. Early stopping reduce the high variance associated with the later stages of training. Parameter impact dropout introduce a new hyperparameter, the dropout rate, the fraction of neurons to drop. Early stopping introduce new hyperparameter, the patient number of epoch to wait and minimum delta, minimum improvement required. Inference test time disabled, dropout disabled. All neurons are used, but weight are typically scaled down by the dropout rate. Early stopping, no impact. The final selected model is used as is. Computational cost. Dropout increases the per epoch training time due to the random masking operation. Early stopping reduce the overall training time by stopping the process sooner. Moving to question different, the statistical significance versus practical significance. Primary question, does statistical significance, does an effect exist? Is result likely due to chance? Practical significance, does the effect matter? Is the result large enough to be useful in the real world? Matrix. Statistical significance measured using p-value or a significance level. Practical significance measured using effect size, example coherence D and R2 lift, A/B test, conversion rate differences, focus, statistical significance rejecting the null hypothesis as zero, practical significance evaluating the magnitude and real world utility of the result, dependency, statistical significance heavily dependent on sample size, very large sample can make trivial effect. Statistically significance, practical significance, the independent of sample size, focus only on scale of the difference or relationship. Threshold, statistical significance, a common threshold is p less than 0.05 means less than a 5% chance the result is random. Practical significance, the threshold is subject to and depends on the business context. Example, we need at least 3% uplift in sales. Risk, statistical significance can lead to false claim of importance if the effect is tiny but p-value is low. Help, practical significance helps prevent investing resources into effects that are real but too small to justify the effort. Causality, statistical significance does not imply causation or practical usefulness. Practical significance still does not imply causation but suggests the relationship if cause is meaningful. Example, in ML, statistical significance, a p-value confirmed a model's R2 is non-zero. Practical significance, the R2 value is zero point 0.9, indicating the model explained 90% of variance, a high practical significance. Moving question, difference between structured data, unstructured data format, highly organized and conformed to a fixed schema, row and column. Unstructured data lack a predefined schema or internal structure. Data type, structured data typically stored in relational data sets, SQL and data warehouse. Unstructured data typically stored in data lake, NoSQL data sets, and document stored. Ease of querying, structured data easy to search, query and aggregate using SQL. Unstructured data difficult to query directly, often requires search indexes, natural language processing or deep learning. Flexibility, structured data low flexibility, schema changes require significant overhead. Unstructured data high flexibility, easy to ingest and store varied format, volume, structured data, historically smaller volume but now scale with modern data warehouse. Unstructured data represent a vast majority, 80 to 90% of generated data, big data analysis. Structured data uses standard BI, statistical methods and traditional ML algorithm. Unstructured data requires advanced ML, CNN, RNN transformers for feature extraction and analysis. Storage cost. Structured data often higher cost per unit due to optimization for querying. Unstructured data generally lower cost due to the commodity storage. Example, structured data, transactions, records, financial data, customer IDs, timestamp. Unstructured data, emails, image, videos, audio files, social media post, raw sensor data. Difference between training set, validation set, and test set. Primary purpose to fit the model, learn the parameter weights in training set. Validation set to tune hyperparameter and perform model selection, compare different model. Test set to provide final unbiased evaluation. Data usage, training set used repeatedly in inner optimization loop, gradient descent. Validation set used repeatedly to evaluate performance after each hyperparameter change or epoch. Test set used only once at the very end of the project lifecycle. Information leakage, training set by designing the model sees and learn from this data. Validation set model weights do not directly learn from this data, but the human algorithm uses its result to refine the model. Indirect leakage, test set must be kept completely separated. No information must leak into the training or validation phase. Typical size, training set, largest portion usually 60 to 80% of the total data. Validation set, medium portion usually 10 to 20% of the total data. Test set, smallest portion usually 10 to 20% of the total data. Error monitored in training set, training error should decreases more monotonically. Validation set, validation error used to detect overfitting and stop training. Test set, test error, the final published generalization error. Role in overfitting, training set, training error decreases rapidly, which is source of overfitting. Validation set, validation error starts to increase, which is the detector of overfitting used for early stopping. Test set, test error being high relative to training error confirms the degree of overfitting. Analogy, training set practice questions a student studies from. Validation set practice exam used to gauge preparedness and adjust study strategy. Test set, the final grade exam given only once. When to use, training set used in the model fit method. Validation set used in grid search, random search or manual tuning loops. Test set used in the model evaluation or model score method saved for final report. Please like, subscribe and share the channel. Thank you.